Happy day, YouTube. My name is John and this is my channel, The Intermancer. The last video was kind of just a cleanup video where I shared a little bit of lessons learned from my last recording experience, because I record several of these videos all at once and then edit them as I can. But it is at this point when we start defining breeding behavior. This genetic AI approach that I've been following involves defining a way for your organisms to breed. That way, when I eventually get to running experiments and evaluating my organisms, I'll be able to breed my more successful organisms to hopefully give rise to even more successful organisms over time. The two things that need to happen there is both breeding and mutation, so that you introduce randomness and you compare and then you combine all of your different pieces in interesting ways. So we're going to start with the breeding behavior, and then I'm going to move on to start defining the mutation behavior. And as I said before, it might be a little bit ambitious of me to think that I'm going to do both of those in one branch. So this branch here might be a little bit long-lived. We'll see. Okay. Organism repo. Let's look at these genes. Let's look at how organisms breed. As you can see from my context document, I've defined things in dependency order. So the most basic thing, like a data quantum, has been defined first, and then the data quantum consumer interface was defined. Then I started with genes at the lowest level, and then chromosome, and then organism. So organisms are way down here, and now we're going to start defining the breeding behavior for organisms. But I don't think that I want to build that into organism itself, because I can think of lots of different strategies by which I will want to combine the genetic organism or genetic material from different organisms. But I also have a most basic default version that I'm going to do. So after organism, I will start defining the organism breeder interface. Interface for breeder for classes that breed one or more, two or more organisms in order to generate descendants that are combinations. That are some sort of combination of the genetic material of their ancestors. That's all right. 1, 2, 3, 4. Methods. So list organism breed list of organism. Real simple. Returns a list of unique of organisms that have been generated based on some sort of combination of the parents of the parental organisms that are originally that are provided as arguments. Okay, that's really simple. And now my basic breeder. The basic breeder is the basic breeder will combine the parental organisms, will return the same number of children organisms as the parents were provided, as the number of children as there are parents. It will uses a shift strategy. So that child, okay, now I'm a mathematician. I think in terms of math. I write in terms of math. You can see the way I structure my context documents. So the way I have thought about this strategy is very mathematical, and that's going to come out in how I say it here. But we'll see how it goes. So that the nth chromosome of a child is the nth of, so that for child X chromosome Y is the same as chromosome Y from parent so that, okay, how do I describe this? So that uses a shift strategy. Let's see if we can just, I'm going to put in a description and then I'm going to ask the AI to help me improve my description. That's what I'm going to do. The basic breeder will return the same number of children organisms as there are parents. It uses a shift strategy. The first chromosome of the first child is the same as is a copy of is a clone of the first chromosome of the first parent. The second chromosome of the first child is a clone of the second chromosome of the second parent. Any parents are referred to, are indexed, are referenced using a mod of the chromosome count. Parents are referenced using a mod of the chromosome count based on the number of parents. So, okay, let's do this. I'm going to make this a new paragraph. And here I am going to say the first chromosome. Here, let's just copy it. Copy that, paste that. The second child is a clone of the first chromosome of the second parent. The second chromosome of the second child is a clone of the second chromosome of the third parent. Parents are referenced and this continues and so on, and so on. Okay. This repeated language here is not the way I would write for a human audience. But neither is it code. So I'm not writing for strictly in code terms. So this context-driven coding style is definitely something in between what I would give to a human for comprehension and what I'm used to giving to a computer. So let's see how this goes. Parents are referenced using a mod of the chromosome. So if there are only two parents, the third parent refers to the first parent. Okay, that's good. That's good. If a parent this combination strategy continues so that all of the genetic continues to the and includes all of the genetic material of all of the parents, even if they are unequal, even if they have unequal numbers of chromosomes. Okay. I'm going to push this up to the repo, refresh the project context in Claude, and I'm going to see if Claude can help me describe this behavior better. Let's save that. Wow, 14%. Okay. I have described basic breeder in organic classes.md, but I think the description could be better. Suggest write 3 different descriptions of basic breeder based on what I have provided. Let's see if that gives me better suggestions. This is one of those tricks that I've been learning that is not something that I'm used to doing. Asking the LLM how I could improve my context. And this is one of those little tricks that I feel like I had to practice my dialogue with the LLM for it to really occur to me. I didn't make it up. I have learned just about everything I've been doing from watching YouTube videos on prompt engineering, but it's one thing to watch a video on something and it's an entirely different thing to do something. And so I had to see videos tell me how to ask the LLM for a better way to prompt the LLM. I had to see that described to me a few times before it occurred to me where I could actually make effective use of that technique in what I was doing. Okay. Description 1. Let's see how it goes. Technical implementation focus. Basic Breeder implements the organism breeder interface with a deterministic chromosome shifting algorithm. For in-parent organisms, it produces in-child organisms by systematically rotating chromosome assignments. Each child's chromosomes are cloned from different parents in a circular pattern. The ith chromosome of child J comes from parent I plus J minus 1 mod parent count. That's good. That's good. I love that. That's what I was trying to say. This ensures genetic diversity through controlled recombination without mutation. The implementation handles parents with uneven chromosome counts by using modular arithmetic to select, it says modular, but it's mod. Anyway, modular arithmetic to select appropriate parent chromosomes, guaranteeing all genetic parent material is utilized regardless of chromosome distribution across parents. This approach creates predictable offspring with mixed genetic lineages while preserving the integrity of individual chromosomes. Now, I don't need all of that description of why it's doing that. I think I can probably stop at this parent count, although I will say that instead of setting chromosome I, we will just call the chromosome, the organism dot get chromosomes dot add method, so that it handles the uneven sizes of parents. Anyway, let's keep going with the reading. Basic breeder functions like a genetic carousel, creating children by rotating parental chromosomes. Imagine parents standing in a circle, each holding their chromosomes in order. To create child I, take the first chromosome from parent 1, the second from parent 2, and so on, cycling back to parent 1 when you run out of parents. For child 2, shift one position. Take the first chromosome from parent 2, the second from parent 3, etc. This pattern continues until you've created as many children as there were parents. The chromosomes themselves aren't modified, only rearranged across generations, ensuring that all genetic material from all parents is preserved. That one's clear. I like that. I might take that one. Description 3, example-based. Ooh. I know I'm not going to take this one. Too wordy, too much. It's going to be one of these other two. I'm not even going to read those out loud, if it exists. Fourth chromosome, if it exists, yeah. Ask parent 1 for chromosome 1. For child 2, okay. I like this. We're going to try this. Basic breeder functions. Oof, I like the mathematics of this. I like the mathematics here. Produces by systematically rotating chromosomes assignments. Each child's chromosomes are cloned from different parents in a circular pattern. I'm going with this one. Okay, so let's take this. Okay. Basic Breeder implements the organism breeder interface with a deterministic chromosome shifting algorithm. For in-parent organisms, it produces in-child organisms by systematically rotating chromosome assignments. Each child's chromosomes are cloned from different parents in a circular pattern. The ith chromosome of child J comes from parent I plus J minus 1 mod parent count. If that parent does not have the necessary number of chromosomes, nothing is added to that child, but there is no error. That's the problem with this. That's the problem with this. Okay, I'm going to go back to the circle one. I'm going to go back to that circle description. Functions and cycling back to run out. Okay. For child 2, okay, let's try this. I think this is going to be able to capture everything. Plus, so the thing I'm wrestling with is that if you get to a parent and you say, okay, give me your 5th chromosome, and the parent says, well, I only had 4 chromosomes, then that's not an error condition in any way, and I don't want there to be any errors there. So I'm having a hard time figuring out how to say that cleanly. That's why I'm asking the AI to help me say things cleanly. To create child 1, run out of parents. And cycling back for child 2, this pattern continues. Okay. This pattern continues until you've created as many children. Also, all parental chromosomes should be included in the generation of children. So the implementation must ask, must not ask, must not go out. Let's just see what happens here. Let's see what this does. Let's just see what this does. Save this, push it up. Second draft of Basic Breeder based on suggestion from Claude. Commit and push. And over here in Claude, see, I can't update the context. It's already got the context from the project. So I go to the projects, I add a new one, I refresh this, wait for that to happen. Generate the organism breeder interface and .java interface and the basic breeder implementation. Okay. Okay, that was easy. UUID, it needed to give me a new ID for each child. That is great. Get max chromosome. Okay. Let's see how this looks. Get maximum chromosome count. Int. Okay. So first off, let's go ahead and add this. This is easy. We're gonna copy this, come back over to the code, and in here, in organism, gene basic. Do I want to put it in a new package? I've got experiment. I've got organism. Is this repo? Okay, so here's the thing. Should I have organism and have the breeding stuff in here, or have it its own package? Organism dot breeding. It's going to be in its new package. Organism breeder and its concrete and its default, the ones that we got here. Its default concrete implementations are part of are in the breeding package, which extends from the package for organism package. Okay. So here I'll say new Java package, organism breeding, and here I'll add a new Java file, interface, organism breeder. And I'll go and put everything there, but I gotta fix the package. breeding. Save that. Oh. Here, we'll just go ahead and, ooh, how do I do that? Ordinate. Quick fix. Okay, save that. And see, so I did the quick fix for that because I'm pretty sure Claude would have given me the import and everything if I'd included that previously. So organic classes, I do want to change this to basic organism breeder. Okay, got that. But we're going to just go ahead and do a new Java file class. Basic organism breeder. And then for this thing, take this, copy. This I'm going to have to correct quite a few things. So this should be breeding. Again, that's something I know the context is going to fix for me. Importing this. Does that fix all of my problems? Oh, excellent. Okay, now let's see. Now that I'm here, let's fix the ID, child ID, UUID, random UID, toString, substring, begin index. Okay, so it's using the 8. Okay, that's fine. But do I need offspring? A class UID represents end index. The least significant long consists of following unsigned. Time low, time most following unsigned, version, time high. Okay, random UID is generated by strong. Okay, 8. Sure, we'll take that, but I'm going to change my description of organic classes. Children are given a random ID with no set prefix or suffix. Okay, and I'm just going to take that out. Everything else here fits. I don't want this offspring, okay, because if I use offspring here, then everything is going to be offspring this, offspring that forever. So we're just going to get rid of that. Okay. Child. For int number of children. Okay. Number of children is parents.size. Okay. Children equals new number of children. Got it. So same number of children as the number of parents. That's all good. For child ID, for the number of children. Okay. Organism child, new organism child ID. Excellent. Number of chromosomes to collect, use maximum from any parent. Get max, okay. We don't need to calculate this based every freaking time. So I'm just going to take this out and put it up here. And shift tab that. Outdent that. 4 chromosomes from parents in rotating order. Max chromosomes, chrome position, parent index 1 plus chrome position I. Where's I? Okay, for this child, plus chrome position. So for the first child, first at 0 mod parent size. That's all good. Parent is parents.get parent index if chrome position, the number of chromosomes, is less than the parent get. Excellent. Add a copy. Chromosome equals Okay, let's fix that real quick. Why is there no? Why does it say that it doesn't like it? Why is it not finding chromosome? Okay, whatever. I'm just going to take care of that. Oops. Chromosome. I don't think that counts as code complete, or that's not a suggestion. That's just completing the code, which is fine. I'm not going to worry about that. Okay. If chrome position, then and child add. Perfect. Perfect. Okay. I'm going to push this up to the repo. Then I'm going to see, and then I'm going to refresh the project, and then I'm going to see if the project sees these new classes. And then I'm going to ask for some tests, a test of organism breeder, basic breeder, basic breeder, basic. Here, rename this. Did I already rename it over here? It just fixed it for me. Basic organism breeder. I think I just made the change. We'll rename it here. Rename basic organism breeder. Okay. All right. Now let's see. Organic classes, need to add that. Add all this. First draft of basic organism breeder .java as suggested by Claude with minor modifications. Commit and push. Okay. Everything should work. No problems. Now we'll go over to Claude. Go back to my context, my projects. Do a new chat. Refresh this. Okay, now go into the code and see if it got the new stuff. Organism breeding, basic organism breeder. Excellent. Everything's there like I want it to be. This is fantastic. Write a test class for basic organism breeder. That should be easy. Test breed. New basic or parent new organism, parent -1. New chromosome. Okay, do I want to force it to use the genes? Okay, I don't need to use the... I've got a while back, when I was doing the original test classes for organism and chromosome and gene, I had it come up with test genes. Gene test, no, test genes. Okay. So do I need test organisms? I don't think so. I don't think so. So let's just look at what it wrote. Breeder, parents, new array list, children, breeder.breed. Assert true is empty, breeding with no parents, okay. Test breed with null parents list. Okay, This is a nice test because it's making sure that there's no error, when I send a null, and everything does things gracefully. Test breeding with single parent. Okay, parent 1 has 2 chromosomes, adds those chromosomes. Children, breeder.breeds, assert that there's 1. Child is children.get, children. It's not, it has an ID, that's good. Assert not equals, it's a new ID, that's good. Assert equals 2, that it has 2 chromosomes from the one parent. Okay, that's a good test. Test breeding with multiple parents. Parent 1, parent 2, parent 3. Add new test genes. I don't like how each of these only has, oh look, it used test genes. That's nice. It used my test genes class. That's awesome. But then it just goes and does round robin. This is an uninteresting test. Okay, I'm gonna tell it that I don't like that test. Test breed with different chromosome counts. Parent 1, add new test genes. Parent 1, chromosome 2, new chromosome. Okay, parent 1, it adds both of those chromosomes. Parent 2, and then it has just 1 chromosome. Parents, children. Child 1 equals, yeah, second chromosome should be from parent 2. How? Parent 2. Parent 2 C1. What? Parent 2 C1? How's that going to happen? I'm going to take this because I'm pretty sure this is going to fail. Right? Yeah. This should fail. I think this test should fail because parent 2 has 2 chromosomes. Parent 1 has 1 chromosome. So child 1 should have 1 chromosome, which should be P1C1 and P2 and P2C2, which doesn't exist. P2C2. Why would this? Okay, P1C2. So this should just have 1. This should have 2, P2C1 and P1C2. This is correct. This is wrong. This should fail. Okay, test chromosome wrapping in breeding. What's it mean, chromosome wrapping? So create 3 parents with multiple chromosomes. 1, 2, 3. Oh my heavens. Unique IDs, okay. Sure, we could take that, but I'm pretty sure this one at least is going to fail, as it should. It's a bad test. And this one is not very interesting because it just round robins them. So I don't know that I'll keep that. And also I need to confirm that we're doing clone. Are we doing clone? .get. It's not cloning. It's not cloning. Okay, so first off, let's copy this. Okay, I put it in the right package there. That's good. So in test, in organism, I'm going to add a new Java package, breeding. Okay, and a new class for basic organism breeder test. Put in the new one. Save this. That works, or it compiles anyway. What I want to do is I want to run it all. I expect this to fail. Boy, it sure is taking a long time to compile, isn't it? Test results. Expected 3, but was 2. Okay. So we got a couple of failures. One, did we get the failure? Actual traces. Oh, good. Here's that. Let's see. Is it not going? Can I go to the code here? Go to test. Okay, here we are. Test breed with different chromosome counts. What's this? Does this go to line? Go to test. Go to error. Was 1. Right, that's what I said. Okay. So then, really, this should just be expected 1. Assert same. And I'm pretty sure this assert same is going to have to be assert equals assert that are the same object, right? I just want this to be equals because I don't want it to be the same. I want it to be cloned. I noticed, thank goodness I noticed, that it was just copying things. It was just using the same object. It wasn't the same object for each of the chromosomes instead of cloning the chromosomes, because in a bigger system, I don't necessarily, even though this might be causing memory bloat for me to clone these things, I want to allow them to mutate independently. So I'm just going to go with clone behavior rather than reuse behavior. Okay. So that's that. Now this, what's this one? Test, go to test. Test chromosome mapping, expected 3, but was 2. Where's this failure? Okay, let's shrink this. Okay. Probably the same thing. Parent 1 has 2 chromosomes. Parent 2 has 1 chromosome. Parent 3 has 3 chromosomes. So child 1 is going to have 2 chromosomes because it'll get P1C1, nothing from parent 2, and P3C3. Okay. Oh, and it's comparing their IDs. It's comparing their IDs. The chromosome IDs. I only need chromosome. Why do I need chromosome IDs? I need chromosome IDs because of the reference bag behavior on the data points. Oof, I probably don't need that in organism. In data quantum consumer. Organic classes.md. Data quantum consumer get ID. Since Gene can have me, he's Jason. Okay, interface. Gene. A data point. Okay. I'm realizing some things here. And this is part of the process of actually using LLMs to help you code. Because I said earlier that I can't give up my personal responsibility on writing this code. And I'm recognizing some things that I've got wrong. For example, chromosomes don't need an ID. Genes need an ID for data point because I want to be able to trace a signal eventually. So I know that genes need an ID. I also know that organisms need an ID. Because that's how I refer to them in the repo. But there's no reason for chromosomes to have an ID. Okay. Now we've got some interesting stuff to do. And we've got a long video already, so I'm going to stop this at this moment of realization, and in the next video, I'm going to dive into all these changes. Thank you.